Hi everyone, welcome to my video on plotting multiple data sets in a single Excel XY graph. So I'm going to be speaking directly to my students. You know who you are, but this is probably also relevant to anybody who needs a tutorial on this. So let's go ahead and get started. So this experiment that we ran in our lab contained four parts A through D. And so we have basically four sets of data. We're going to split each of these data sections up into separate sections for our purposes today. So you need to find some delta T values. For part A, you need to find two different delta T values, delta T hot and delta T cold. And for parts B through D, you need to find three different delta T values which correspond to the heat changes associated with the reactions indicated here, here, and here. So in parts B, it's a simple reaction between aqueous sodium hydroxide and hydrochloric acid, acid-base reaction. We need to find the associated delta T reaction. In part C, we're looking about the heat of solubility associated with the dissolution of solid sodium hydroxide. So here on the left side of the reaction arrow, we have solid sodium hydroxide. On the right side, we have aqueous sodium hydroxide, indicating that it has dissolved. Now, since sodium and hydroxide are both soluble ions, aqueous sodium hydroxide is dissociated sodium hydroxide. That is, the cation sodium is dissociated from the hydroxide anion in solution. And then in part D, we have solid sodium hydroxide and hydrochloric acid mixed together. And again, it's an acid-base reaction. It's almost the same as the reaction in part B, except that we are working with a solid form of the base rather than a pre-dissolved form. Okay, so I'm not going to get too much into the details of the experiment. I want to focus just on getting the delta T reaction. So for and the delta T hot and delta T cold. So for my students and for any other, associated students, when you look at your lab manual, you're going to notice that you have to solve a few different equations that contain these. So without further ado, let's go ahead and get started. So in part A, we had two different calorimeters, calorimeter A and calorimeter B. We heated up some water and we placed it in calorimeter A. We had some room temperature water in calorimeter B. We recorded the temperature of the water in calorimeter A at 1 minute, 2 minutes, 3 minutes, and 4 minutes after beginning our data collection. So we started our data collection at 0 minutes, but we took our first measurements 1 minute after that time. Hopefully that's not complicated. So notice that the water in calorimeter A is warmer than the water in calorimeter B. The room temperature water in calorimeter B was poured into calorimeter A, so this water at this temperature was mixed with this water at this temperature in calorimeter A at 4.5 minutes or 4 minutes and 30 seconds after starting. So we recorded the temperature of the water in calorimeter A after mixing at 5 minutes, 6 minutes, and 7 minutes. So note that 5 minutes is 5 minutes after our initial start. So just to be super clear, I'm not trying to be redundant, I just want to make sure everybody understands this. We started at 0 minutes. We took measurements of calorimeter A and B at 1, 2, 3, 4 minutes. then at approximately 4.5 minutes, we mixed the contents of calorimeter B with the contents of calorimeter A in calorimeter A, and then we continued recording the temperature of the mixture, the mixed waters in calorimeter A at 5 minutes, 6 minutes, 7 minutes. So all this data represents 7 minutes from start, right? Okay, let's go ahead and graph it. So we need to break this data here in part A into 3 different data sets. And the first data set is going to be the data set of the calorimeter A before mixing. Data set, the second data set is going to be the time and temperature of the water in calorimeter B before mixing. And then the third data set is going to be composed of the time and the temperature of the water in calorimeter A after mixing. So this is how I would do this. I would go ahead and highlight all the data that's going to be in the first data set, and then I would go to Insert, and then Charts, XY Scatter, okay, and then go ahead, right click, go to Select Data. We can add a data series, and I'm just going to be explicit and name these data series. So I'll just call this Cal B Temp in Celsius. And the X values are going to be the time. So at 1 minute, the water in calorimeter B was 23.1, right? So for X values on the X axis, we're going to do minutes. And then the corresponding Y values are, hopefully we can get it without, there we go. We're actually getting this cell down here that you actually is obscured from your vision. Okay, let's go ahead and rename this series. So we're going to edit series 1, and we're going to call it Cal A Temp in Celsius. And then let's be very clear, this is, let's do this before mixing. Let's see here. Okay, and let's add the third data set into this graph now. So we're going to go add, and series name is going to be Cal A Temp, again in Celsius, after mixing. And then the X values are going to be the time after mixing, 5, 6, 7 minutes. Now that's, again, that's not 5 minutes after mixing, that's only about 30 seconds after mixing, right? Because the time of mixing is 4.5 minutes. And then the corresponding Y values, I don't know if we're going to be able to grab those. Let's just go ahead and say OK right now. Okay. And then I'm going to drag this over a little bit. I'm going to go ahead and right click, select data, back to the series we were just working on. Let's go ahead and edit that. Let's go ahead and move this out of the way too. The Y values are going to be the temperatures of the mixed water in calorimeter A. And we're good here. Everything looks good. Okay, so let's go ahead and do chart title. So we're doing this so we can find the calorimeter constant. So we'll just call this cal const, and let's do periods. Cal const, oops, determination. All right, and then let's go ahead and add axis titles. And then our axis title is going to be temp in Celsius. And then our x-axis title is going to be time of measurement, and that's going to be in units of minutes. And then just to be nice, let's go ahead and add an outline. How did that come out? That looks good. And then let's do the same thing here. Let's add the outline. Let's see, how does that look? Oh yes, we must do the axes separately. So let's format the axis. We'll go to the color. We'll do solid line, and we will do black. And then we'll do the same thing. Oops. Down here with the x-axis outline, we'll go black. Let's see. Alright, that's looking pretty good. Now, notice that the time of mixing is 4.5 minutes. I want to add in a vertical line at 4.5 minutes. So I can actually do that by actually adding in a fourth data series to this one plot. And we're going to do 2 points at 4.5 minutes. So we're going to do 4.5, 4.5, and then I'm going to start at 0 and I'm going to go up to 45. Okay? So I'm going to have a point at 4.50 and 4.545, and then I'm going to add a line between those 2 points. So it'll just be a vertical line at that point. So I'm going to go 0. That's temp again, right? And 45. I'm just not labeling it. I'm being a little bit casual with this line right here. This time of mixing line. It corresponds to this. And we'll just go select data, add, and I will just call it TOM. And the X values are here, and the corresponding Y values are right here. Let's go OK, OK, and then we're going to format data series, go to the color, go to solid line, and let's make that a little thinner. So we'll go 1. How about, let's see, we'll go ahead 1.25. So when we did that, it automatically adjusted the y-axis. So let's go ahead and scale that back to its original values. It's going to be here. Axis options. We're going to go to maximum 45. Okay, that looks pretty good. Let's go ahead and also add in a legend, just so we know which data series we're looking at. And then I'm going to go ahead and scale this a little bit. Let's see what we can do with this. And then let's go ahead and kind of drag this back as it was. Okay, so I mean, you can always spend more time messing around on this. Like you want to add a border here, go for it. And it's nice to have nice looking plots. It really does help out. If everything is a little bit too messy, sometimes it would be hard to understand your data. Okay, so we now actually have 4 data series in this one plot. One of those data series is just that vertical line. Let's go ahead and get the trend lines now for each of these data series. So we're going to add trend line. It's going to be linear. I'm going to have it go ahead and intersect the time of mixing line. So this last data point is at 4 minutes. The time of mixing is at 4.5. So I'm going to forecast forward 0.5. I'm going to go ahead and forecast backwards 1. And actually, I'm going to go ahead and change this line type a little bit. I'm going to make it solid. And then we're going to do the same thing with the other two data series. Add a trend line. We're going to go forward 0.5. We're going to go backwards 1. We're going to change the type to solid. And then we'll do that one more time. Add trend line. We'll do backwards this time 0.5, and we'll do forward. We'll just go forward 1. Why not? And let's see how that looks. Oh, let's go ahead and readjust this axis again. So sometimes it's a little bit annoying how Excel will automatically readjust axes. It's not that big of a deal, but it does add an extra step. And actually, I want to go back to 8, don't I? Let's go to 8. 8, and we're going to go back to 0 as well. There we go. Okay, but let's go ahead and change this to a solid line as well. Alright, so there's two ways to do this now. I'm going to actually go ahead and do it the formal way. So let's go ahead and get the equation in the line for each of these 3 lines here. Each of these 3 data set lines, not referencing the time of mixing line. So for this first one, I want to display the equation on the chart, and I'm not going to worry about the r squared value in this case. Let's do that again here. Okay, so we now have these 3 equations. Each of these equations actually reflect the temperature of the water at a time. So I'm going to go ahead and change these equations to represent that. Temp in Celsius, that's the y-axis, right? And then we're going to go times time, and that's going to be in minutes. Oops. There we go. Let me move this back here a little bit. Okay, that looks pretty good. Now go ahead and do this with each of the equations, or at least make sure that you understand that y is temp and x is time in minutes. Now we need to solve for the temperature at the time of mixing. We need to solve for this point right here, this point right here, and this point right here. This point is going to be T initial hot. This point right here is going to be T initial cold. And this point right here is going to be T final hot and cold. We want to get this delta T right here that reflects the difference between this point and this point. That's going to reflect delta T hot. And we want to get this delta T right here along the time of mixing line. This delta T is based on the change in the room temperature or cold water. So every time we do a delta T, we always take final minus initial. So this delta T is going to be equal to this temperature minus this temperature. And this delta T right here is going to be equal to this temperature minus this temperature. So because this point, this temperature is higher than this one, this delta T is going to be positive, Whereas for the delta T hot component, this point, the final temperature after mixing, is less than the temperature before. We have this temperature minus this temperature. This delta T is going to be negative, and these signs are important. Now, what we could do here is we could plug in 4.5 for time in minutes, and then we would get negative 0.04 times 4.5, and then we would add 40.15 to the product, and that would give us the exact temperature in degrees Celsius at time of mixing for the hot water. But I'm going to be easy. I'm going to let you guys go ahead and just approximate, just with your best guess, exactly what this temperature measurement is, exactly what this temperature measurement is, and exactly what this temperature measurement is. So let's take a look. Let's take a look at delta T hot. Well, delta T hot is going to be equal to some negative value, right? Let me make sure that's not a subscript. So you can do superscripts and subscripts in this manner in Excel. So let's go. Delta T hot equals, okay, that looks better. What does it equal? Well, it's going to be negative. We know that. I'm going to say that this temperature right here is about I'm going to say 34. And this temperature right here is about 40. So 34 minus 40, and I'll say 34.0, 40.0. 34.0 minus 40.0 is going to be negative 6.0. So that's going to be delta T hot. Delta T cold, let me make sure it's not a subscript again, or a superscript. Okay, oops. Let's go ahead and change that. Home, subscript, okay, and then equals, but we don't want that to be a subscript. Home, font, subscript, okay. Now, again, delta T cold is going to be a positive value, right? Because we always take final minus initial when we do a delta T. So I'm going to say this temperature again, we're going to use the same one, is 34.0. And this temperature right here, we're going to take it as 23.1. I'm getting that really from here, right? So 34.0 minus 23.1 is going to be, let me use my calculator, 34, let's just go ahead and solve it on here, equals 34.0 minus 23.1. That's 10.9. So delta T cold is equal to 10.9. So once you have these delta T values from this graph, you can solve the equation for determination of calorimeter constant. So this is how you can do the first graph. So hopefully that's not too hard, and you're able to include that on your lab report. I'm going to be looking for these graphs. So please let me know if it's too difficult to generate these graphs. Okay, now let's take a look at part B. Part B is going to be basically the same as part A. The only thing is you have a data set here. This is the temperature of the solution in calorimeter A at minute 1, minute 2, minute 3. And then you also have this second data series, which is, time at 1, 2, 3 minutes, and the temperature of the solution in calorimeter B at 1, 2, and 3 minutes. And then the third data series is going to be after mixing at 4 minutes, 5 minutes, 6 minutes, 7 minutes, and 8 minutes. And so the temperature, at least in my arbitrary values, increased after mixing the two solutions together. And I recorded those temperatures at 4, 5, 6, 7, and 8 minutes. Now, in this case, in part B, and also in parts C and D, the time of mixing is probably 3.5 minutes. Now, your data may be slightly different than mine, but time of mixing should be about 3.5 minutes. Maybe it's 4.5 minutes, maybe it's 2.5 minutes, depending upon exactly how you executed the experiment. Now, for parts B, C, and D, you actually need to get delta T reaction rather than a delta T hot and a delta T cold. So in part B, we can do the same thing we did in part A, but we can actually get away with graphing just either the temperature of the solution in calorimeter A or the temperature of the solution in calorimeter B before mixing, since they're basically identical. Or you can graph them both and they're just going to be overlapping. Now, what we want to do in part B is just graph either this one or this one, XY scatter. Let's go ahead and move it out of the way. And I'll just say after mixing in this case. The X values are going to be at 4, 5, 6, 7, 8. And the Y values, are going to be the temperature in calorimeter B after mixing, because we mixed these solutions together in calorimeter B. Let's see how that looks. So this represents an exothermic process, right? Because we had two solutions at basically the same identical temperature, and then after mixing, the temperature went up. So I want you to do the same thing. I'm not going to go through all the steps again. I want you to put the time of mixing line in, this time at 3.5 minutes. I want you to get the trend line here, the trend line here. Go ahead and extrapolate to the time of mixing, and then you can just eyeball, approximate based on your data and also what you see in the graph, the temperature at time of mixing. This point up here is going to be time of mixing. This is going to be temperature final, right? After mixing, temperature final. And this point down here where I'm holding the cursor is going to be temperature initial. So again, it's final minus initial. Since this temperature is larger than this temperature, delta T reaction is going to be positive, right? Okay, hopefully that makes sense. And then in parts C and D, you're going to do, you're going to do exactly the same thing that you're doing here. And that's pretty much it. Hopefully that was clear enough. Hopefully it's not confusing. Please contact me if you have any questions whatsoever. But basically this part here indicates how to do multiple data series or data sets in a single graph. All right, everybody. Hope that was informative. Hope that's clear. Good luck. And again, feel free to contact me with any questions. Okay, thanks. Have a great day.